Hello, good evening, everyone. Am I audible?
Yes, ma'am, you are audible.
Yeah, thank you. So we'll start the session in another 1 or 2 minutes. Okay, let's just see if more people are joining. Another 1 or 2 minutes. Okay, so welcome everyone. So today we start off with the first live session for this term in programming concepts using Java course. Are you all able to access the content of the course, the lectures, and the activity questions and assignments and everything?
Yes.
So can you just give me some numbers on how many people have already watched the lectures? So I have some idea about, what the
I've done till 1.5, video number 1.5.
Not completed, ma'am. Half only, ma'am.
okay, fine, sure. No issues, yeah.
This is more of a theoretical, right?
Yeah, it's very much theoretical. This week is very much theoretical.
Yeah.
In fact, we start off with concepts on Java and next week only.
Okay.
This week it's general programming.
Is it going to like this kind of theory question are going to come in the main?
No, generally not. We may have few match the following questions, one or two maybe one question per exam or something like that. I mean, I'm not saying that's the only number, but generally yes, one question maybe. Something like a match the following, right? So some object-oriented concepts are there and what each of them mean and all that. Generally, it's about testing the concepts rather than recalling the concepts.
Okay. Yeah.
Okay. Yeah. So shall we start off? Okay.
Yes, ma'am.
Sure. Thanks. Just share my screen. Let me see if I can do that. Okay. So this week, sir is actually starting off with concepts on programming languages, right? So what is a language in its strictest sense, right? It's something that we use for communication, basically. So there are two parties who want to communicate, and you use something called as language. So that this should be something that is known to both people. Otherwise, you cannot communicate. Of course, Chinese is a language, English is a language, but I can speak English, but if somebody speaks in Chinese, I cannot understand. So this language has to be understood by The person who is trying to communicate and the person who is being communicated to. Right? So that is the purpose of the language. So the programming language, the purpose of the programming language is for interaction between the humans and the computers. So again, we have two people who are two entities which are communicating. And the person who is communicating the entity that is communicating, when we are giving inputs, when we are trying to make the computer do something via the programs, right? So we are trying to communicate something to the computer, and the computer has to understand what we are trying to communicate. So if we tell the computer in Chinese, probably it will not understand. If we tell the computer in English, it will probably not understand. So we have specifically designed programming languages which have their own translators, which will come to, which will enable a communication, an effective communication channel between humans and computers. So this is what a programming language is. So the purpose of programming language, as I said, is effective communication. But I, as a human being, cannot interact in a language that the computer as a physical hardware can understand. Because computer as a hardware can only understand zeros and ones, right? You call it as bits, no? It can only understand zeros and ones. So what is the zeros and ones coming from? There are semiconductor devices which have this on and off state. Symbolically, an on state represents one of the either 0 or 1, and the off state represents the other. So this is all that the computer hardware can understand. So, but I cannot communicate it in terms of zeros and ones because I do not know. Like, I mean, a real computer expert, hardware expert might probably be able to do that. But in general, we cannot do it. A typical programmer cannot do that. So then what we have is translators. Translators between the language that I know and translators between the language that I know and the language that the computer understands. So the programming language in which I write the code, right? So these are called the high-level languages. Okay. So these are all like basic dry theory. People who have good basics in computer science probably would know all these things very well. So you want to communicate with the computer, and what the languages that I know are like C, C++, Java, Python, right? These are the high-level languages. But these are not directly understandable by the computer. The computer can only understand what we call as a low-level or machine-level languages, right? Which are in zeros and ones, which are streams of, I would say, sequences of zeros and ones, right? So this language, this translation has to happen from the high-level languages to low-level machine languages. And these are done by translators. These are again softwares. Okay. These are translators, which are typically of two types. It could either be a compiler or an interpreter. Okay. So far, good?
Yes, ma'am.
Yes. Okay. Now, as you all know, like Python, the language that you're all familiar with, it uses an interpreter. The code that we write in Python is translated to the low-level language using an interpreter. In the case of Java, there are two phases that happens, but generally we call Java as a compiled language, but still you have two phases that is happening. Java code is compiled into what is known as class file, or we call it as an object code. This class file is then executed at the place where we want to actually execute the code. And there it is actually converted into the executable code. This is happening at the place where we want to execute the code. So in general, Java is a compiled language. And it is compiled into what is known as an object code. So the Java part that we will come to it when we need to specifically learn about Java. But for now, we are going to stick to some general programming concepts. Okay. Now, there are different programs. Yeah, somebody wants to ask something?
Am I audible?
Yeah.
Yeah. So what is the difference between a compiler and a interpreter?
Oh, yeah. Okay, so coming to that, yeah. So what happens in a, so when you say a program is getting executed, what is happening? You have secondary memory here. What is secondary memory? It is your hard disk. That is secondary memory, right? Or some other permanent storage. That is what it means by this. Okay. And then you have the RAM, which is the main memory. Okay, this is not permanent storage. This is volatile storage. This is the organization of memory inside the computer. Okay, this is volatile storage, whereas this is permanent storage. Now this is the CPU. So when CPU wants to execute the instructions, CPU wants to execute the program that we have written, right? What it does is it executes one instruction after the. Okay, so you have a RAM here, and you have these memory locations. Each will have some one instruction per line. So CPU goes to this line, executes the statement. In the case of Python, in the case of interpreted languages, what happens is it fetches one, or rather it will have the program here, but it will take the first line of code, convert it to machine language, execute it, and then go to the next line of code. So high-level language code is converted to the machine language code. So it is interpreted line by line. That is an interpretation. Every line, the first line it accesses, it converts into a machine code and then it executes it. In the case of compilation, what it does is it takes the full program from the hard disk, loads into the RAM, compiles it together. The whole set of instructions are compiled into machine language. And then the execution begins from one step to the other. Okay. So compilation means it is like, it is processed as a whole. Whereas interpreted means it is something like a line by line processing. Got it? So in the case of Python, it uses an interpreter where it does is line by line. In the case of compilation, it takes the whole program, compiles the whole thing into machine code, and then starts executing from the first instruction onwards. Got it? No? So see, for instance, C, C++, Java, all these languages are compiled, like they use compilers. Whereas Python, there is something called basic. I don't know if you know about it. These are all like interpreted languages. So depending on, many factors, like some of them have advantages, other has, one has certain advantages, the other has certain advantages. Is this clear?
Ma'am, I have two doubts over here.
Sorry?
I have some doubts. Can I?
Yeah.
So when you're saying it is whole program is basically compiled and then basically it gives the output. So when we are talking about the whole program, is it a class-wise or function-wise or something like this? Because we know program basically executes on the main function. So like at what level it basically decides that this much of program should be compiled first and then
it compiles the full program. When you say something like a .c file, right? It compiles a full C file. When you say .java file, it compiles a full Java file.
Okay.
It doesn't stop at one class or one method or anything. It doesn't, it doesn't split into modules or anything. It will compile the whole thing.
Okay.
And it will generate a .class. In the case of Java, it generates a .class file. In the case of C, it generates a .exe file.
And what would be the content of a .class file inside Java? Like, is it a
.class file, right? Yeah, it will be a combination of English plus certain binary.
Okay.
So, okay, I will tell you what is happening. So, because you're asking, I can tell you. See, Java, we know is something like maybe you have heard of it. It's a platform independent language is what we are saying, right? So that comes because whatever Java compiles into this object code, right? This object code is same for all machines. When Java, the .java file is compiled into what I call as a .class file, this .class file is the same file which is generated for all the, for a given Java file, it is the same class file. But if I'm running on some Intel machine, if I'm running on some other machine, right? So then depending on the computer architecture, the executable code changes. Which means that, say, for instance, in the case of, say, Pentium, Intel something, they use, say, 32 bits for integers. Some other processor might be using 64-bit. It is also dependent on the operating system. So the executable code has certain specifics which are specific to the computer architecture. Say, for instance, how much memory has to be allocated for an integer, how much memory has to be allocated for a string. All these are like architecture dependent or the operating system dependent, system dependent, you can say. These things are done in the second stage, where the .class file is taken to the machine where it is going to be run, and there it is getting converted to the executable code depending on the architecture of the underlying computer. Okay, so am I clear or am I confusing you more? Is it okay?
Yeah, fine.
Got it? No? Okay. So this is what makes Java platform independent. In the sense that the class file is independent of the platform on which it is going to be executed, independent of the computer architecture on which it is going to be executed. Whereas the final executable code is still dependent on the computer architecture on which it has to be executed, and that will happen during the runtime. Got it?
Yeah.
So you were able to ask something else also. I think I interrupted you at that point.
Yeah, actually, like if I wrote something like system.out.println, let's say hello world. So it will be converted to 0, 1, 1, something like that of that code.
Yeah, that's what I'm saying. So whatever is not system specific, right? That can be converted into the binary already. Then in the class file, that will have the binary code only. Whatever is platform independent. Whatever is platform dependent can only be converted when it is physically taken to that machine. So at that point, those things are converted only at that stage. So you can just open a .class file and you will see that it is a combination of English alphabets and words and letters and all that, plus some junk which you cannot read, which are already the converted.
Fine.
Okay.
Yeah, thank you.
But in case of C, C++, etc., what happens is the compiler itself is architecture dependent. That is, for a particular compiler, for a particular machine, you need to have a particular compiler. In that case, the compiler itself will convert the high-level language to the computer architecture of the machine on which it is supposed to run. Got it? So directly converting to executable code, which is computer architecture dependent. So the compiler itself changes from one machine to another.
Ma'am, is it true for today? Like in today's time also, like I think like when I use C in my system, I don't think I need a different compiler if I use in different machine.
No, but is it like, I mean, if you look at on something like, you have a 16 MB RAM and something like the 2 GB RAM that we have right now, are they still same?
No, they are not.
Yeah, so that is what some dependency will be there, is what I'm saying.
Okay.
Yeah, again, all these do not have a clear boundaries at all times. These are all like generic concepts. I will always say this to you, like these are all generic concepts. We cannot look for a fine line between all these ideas because they're all kind of overlapping these days. Okay. So these are all like theory, hardcore theory. So in practical scenarios, there will be a lot of overlap between these. Okay.
Ma'am, at the risk of digressing, so this platform independence of Java has this JVM also got to do with that? I mean, is there the Java virtual machine that it runs on?
Yeah, so in the local machine that it is running, you need to have something which is platform dependent, right? Otherwise, it cannot convert it to the architecture. I mean, it cannot convert the code into an executable code which is architecture dependent.
Okay, so JVM does that part, is what you're saying.
Correct. Yeah. Whatever is
Okay.
there on the client part, that is what it does.
So, ma'am,
Virtual machine.
so ma'am, what does the JRE does then, ma'am, in that case? Like you said, like JVM provides the environment, right?
What is
compile.
JR?
Yeah.
What exactly do you mean by JRE?
It's a Java runtime environment, ma'am.
Yeah.
JRE.
Okay. Okay. So, Anand, do you want to answer that? Do you want to like?
See, I have like
One second.
yeah.
One second. Anand knows better to answer that, I think.
Yeah, actually here JVM provides Java runtime environment for our Java program. Okay, so here Java runtime environment is provided by the JVM. Okay, so here runtime support, okay, is given by the JRE. Okay, who will provide that runtime environment for your Java program at runtime is JVM. Okay, so here JVM is installed on your system. So whenever you install JDK, so automatically JVM also installed. So here JVM is platform dependent. So based on your operating system.
Anand, let me interrupt you. Let me interrupt you here. See, the reason to ask me this question. Okay, suppose my JDK is a 1.4. Okay,
Yeah.
and whatever JVM I just compiled my thing and I'm deploying the my Java file to some other environment where the where the Java version is at least 1.6 or higher version. So can I will it be backward compatible? I mean, because my JDK develop is a 1.4. Okay, so that's what my question is: how the JVM and the JRE will support the Java 1.4 compiled this Java file, sir. That's what my actually reason.
Yeah. You can actually if you execute in your sorry, if you execute the program in any IDE, so it will ask you to upgrade the version. So there is we have one option like we are able to update the version, but if you run it manually, it is not possible.
But IDs are the IDs for the development, right? Is a NetBeans ID or like some other. They are for development thing. But what I'm saying is about deployment. Okay, suppose you have done the development in your application in your local environment where you have the JDK 1.4. Fine. Now you have to deploy this change to the machine, to the server. Okay, where the JRE, where the Java version is 1.6 and higher. Okay.
Yeah.
Of course, on the server you won't be having IDE, right? You won't be having IDE. So in that case, how JVM will...
Yeah, what is your question? I did not get your question. So what you mean is you developed in a lower version and you want to deploy it in a higher version environment. Is that what you mean?
Yes. So how JVM will help? JVM or JRE? So that will be backward compatible, right? Because Java is a 1.4.
So what is the problem in that? I don't understand. Why would it not be backward compatible? See, forward compatibility will be difficult because if you have an advanced version in which you have developed and the deployment machine has a lower version, like earlier version, there will be a problem, right? Otherwise, what is the problem?
What I want to ask, like, will it prepare the environment for the Java 1.4?
I don't think it will create a problem because if your development is on an earlier version, deployment is on a later version, there should be upward compatibility. But I'm not sure. I am not.
So reverse is not true. You mean to say reverse is not true? Like for 1.6 to 1.4, suppose you develop in the 1.6 and if you
it may not be is what I'm assuming, because you see there are so many cases where suppose. Yeah.
So, ma'am, in this situation, don't you think like the platform independent, what we have just now give the term?
Platform independent is different from Java version dependency. Platform independent is the computer architecture dependency. Computer architecture and the operating system dependency. It is not about the JVM version dependency.
So you
it is about the sorry.
So you totally accept like okay, whatever is a platform. what you must have the compatible environment like JVM or
Yeah,
Java
of course.
version
So when you say
on the other
platform
machine.
independent, when you say platform independent, it is only till the class file is generated. Ultimately, when you want to run on the architecture, you must have something. See, if you want to run on the Linux machine, you should have a JVM which is suited for Linux. If you run on the Mac, you should have a JVM which is suited for Mac. If you have if you're running on Windows, you should have suited for that. So the platform compatibility stops until you create the class file, which is what the developer does. In the case of C, even the developer cannot generate the compile file. They have to have the C file transported. And the JVM is a much lighter thing as compared to having a full compiler. So you cannot ask the developer to say, the person to the end user to have the compiler in their machine, compile it and run the executable, right? Of course, you don't want to give them the source code. That's correct, right? Whereas in the case of class file, you give the class file to them and then they run it on the JVM, which is like the effort that is involved in converting a C file to an executable and compare with the .class file to the executable. The JVM takes care of that implicitly is what we are saying. There is no explicit compilation or interpretation that is happening. That is where the platform independent comes. Platform independence.
I'll explore more about this thing, ma'am. Thank you.
Yeah,
Thank
please.
You. Yeah.
When we say platform independent, it does not mean 100% independence. It cannot be.
Yes, ma'am. That's what
that is 0%. That is clearly not possible because depends very much dependent, as I told you, right? The integer number of binary digits required for an integer will differ from architecture to architecture, operating system to operating system. So depending on the, definitely at some point there has to be this choice of platform dependency. But the platform independence comes with what you are giving to the user, right? You give the .class file to all the users, you can give the same .class file. So it stops there. The platform independence stops there.
Yeah, okay, ma'am.
Yeah, so for Java, I think we'll explore more, but may not be to the level of deployment and other things. We will be, so anyway, again coming to that, our focus, so I should keep stressing this again. Our focus is not on how to use Java, our focus is on learning the programming concepts. And for that, we use Java as a tool because here in this course, we are focusing more on the object-oriented concepts. Yeah,
ma'am. May I ask?
Yeah, sure.
Yeah, we are very new to this Java, ma'am. So
yeah,
keep us in your mind also because we don't know anything about Java.
Who is this man? Know your name?
My name is SKP Byahut.
Sorry?
SKP Byahut.
Yeah, okay. So SKP Byahut, see, the thing is, I had no plan to discuss about the platform dependency and independency of Java, but because somebody asked a doubt, I just clarified it. You can totally ignore that part of the discussion. You can just focus on what I'm teaching you because this is all what sir has also taught in the lectures. And I'll try to stick to it. Because somebody was really curious to know about it, I just went ahead with that conversation. And he also specifically mentioned in the risk of digressing, right? So we did digress a bit and we are coming back to the mainstream.
Okay, ma'am.
Okay, so now we have, okay. So let me just ask you one thing.
Just once repeat this class file, ma'am. Just class file once again.
Sorry?
No,
class file is actually not required. Even that is not required here because for Java, we are coming in the next week only.
Okay, ma'am. Okay.
I just mentioned it because I want to differentiate with the compiler and the interpreter. And because we are looking at Java, I wanted to mention about this class file as an intermediate file. So if you're not able to understand it, just leave it for now. Next week, we will again revisit it. If you're not able to understand that point, we'll clarify.
Thank you, ma'am. Okay.
Yeah. So there are many more concepts in this week, like, memory management or things. Those things, if you understand, only then you will understand these specific properties of Java, like the, the dynamic method dispatching. These are, don't worry about these technologies, these are nothing. These are things like we'll teach you as we go. But if you have to understand this, you have to understand a bit about the memory management that happens. Those things is what we wanted to deal with. Okay.
Okay. Thank you.
Yeah. Okay. So have you heard of, of course you would have heard, what are variables? Okay. Can somebody tell me what is a variable?
Variable is the address of the space in the memory.
Correct.
Address of the space. Address of the space in the memory.
Correct. So it's a name that we use to denote a particular location in the memory, correct?
Yeah, thank you.
Now we are saying that the variables have data types. So what are data types? And why is it necessary to have a data type for a variable? So if you see in the memory, As I said, like, the computer understands this language of zeros and ones only. So if you look inside the RAM, as you can see, everything will be like, zeros, ones, 0, 0. Okay, I'm writing some zeros also somewhere. I won't be specific. 1, 1, 0, 0, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 0. Okay. So in main memory, this is all. If you just take a snapshot of the memory, right, this is all what you see, zeros and ones. So we attach something called as typing for the variables. So this is say memory location A. Now, if memory location A has to represent something meaningful, has to say represent something logical, then we have to identify whether it is going to be a number, a string, or anything else, right? This binary sequence of digits do not make any sense unless we attach some logical importance or logical implications of this sequence of bits to it. For that, we identify this sequence of bits as say maybe integer. In that case, A becomes an integer. Suppose this stands for say string B. This is B, location B, and this is of type string. Then this set of sequences is actually representing a string. So that is the purpose of data typing. All you see is the binary digits inside the memory. If you want to allocate something, that is the requirement of having types from the implementation perspective. From the programming perspective, of course, it is required. You know the specifics, right? Why we need data types. We need data types because we want to know like what kind of values can go into it, and then the type, static typing, dynamic typing, all those things will come to that. But for now, the sequence of bits makes logical. We can derive a logical meaning out of the sequence of bits if we attach some types to that particular variable which is representing that memory. Now that is what is meant by the data type. Right? Now there is something called as static typing and dynamic typing. Okay. So in the case of Python, do you know what is used?
Dynamic typing.
Dynamic typing.
Yeah, why?
Dynamic.
The variable assumes the type and the value it is holding at the moment.
Yeah, so you are not explicitly stating, say for instance, you can do I equal to 0 and you can also do I equal to A, right? Is this correct? This is permitted in Python?
Yeah, ma'am.
Yes.
Yes, ma'am.
So you are actually associating some type with this variable in a dynamic sense, right? In one statement, you are saying, okay, it is an integer. In another statement, you are saying it's a string, right? So this is the dynamicity. You are attaching the type in a dynamic manner during runtime. That is the dynamic typing. What happens in languages like Java is static typing. Before using the variable, you must specify as to what this variable is going to represent. Is it going to represent an integer, or is it going to represent a string, or is it going to represent a boolean? This has to be made very clear before starting to use this variable. Now, again, both of them, static typing as well as the dynamic typing, have their own advantages and disadvantages. Can you tell me what is the advantage of dynamic typing? Because you are familiar with that in Python. So can you tell me what is the advantage of dynamic typing?
We do not need to remember the name of the variable.
No, you still need to remember the name of the variable, right? I mean, you don't have to, you cannot forget. You should know what variable you have to use. So remembering variable.
No need to define multiple variable for different type of data actually, ma'am.
For declaration, we don't, I think this is what you're trying to hear. While we don't have to declare specific types of, say there's a variable A, we don't have to specify it like int A or char A or double A like we do in Java. We just have to use it in specific statements, specific ways, and it will allocate accordingly. It will be treated accordingly.
Yeah, so more like you don't have to plan anything, right? You can just
Exactly.
use the variable as you go. Sorry?
However,
Derive from current value.
Yeah, so you can use it as you go. You don't have to pre-plan and say that, okay, I have to define this, I have to use this variable as a string, I have to use this variable as an int. That is not required, right? You don't have to declare it ahead. You don't have to worry about planning. Okay, these are the variables, right? But in the case of, so that is an advantage that the programmer has. It's a programmer's advantage for being able to dynamically associate types with a variable. What is the advantage of static typing? For that, you should know what is the disadvantage of dynamic typing, right? Can you tell me what is the disadvantage of dynamic typing?
It is error prone and slow.
Sorry?
Is like there is a possibility for logical errors or like because of the syntax or if you have a difference in value assigned because it is not fixed to a variable.
Correct.
And it is slower.
Yeah. So the thing is like you are not insisting that you declare ahead, okay, I'm going to use this variable, which means that you have the flexibility to create variables as and when you want. So even when you had actually intended to use one variable, just because you typed it wrongly, Python will just accept it as a variable and move on. Say, for instance, you have, say, alpha equal to alpha, please. Suppose I forgot this h. Actually, my intention was to increment the alpha variable by 1. But even if I forget this h, Python will just accept it, right? But that is
Yes,
not
ma'am.
what I wanted. Yeah. So that is not what I
So
wanted.
a new variable will be
Yeah,
runtime
initialized,
based.
assumed,
Yeah.
and it will be treated to be, something alpha plus 1. But
Correct.
if we declare it beforehand, it will throw us some error that please define
It will
this,
throw
that,
us an error.
blah,
So
blah,
this will actually create a new variable with the value 1. And we will not recognize it because we are, I mean, some of us are really bad at recognizing spelling
won't be
mistakes,
visible,
right?
barely
Yeah, it
visible.
won't be visible, especially when we are writing exams and all that. There is a very likelihood that we might miss out these things, right? So catching errors early on, specifically these kind of typos, right? That is a big advantage that the static typing provides you. We won't get into this kind of typo errors resulting in logical mistakes in the program. Because in the beginning Java, if you want to use ALPA, you have to say, okay, this is int ALPA and ALPHA. Whereas in Python, that is not required. Of course, the flexibility that Python gives you is also a reason for resulting in some kind of a logical error due to some typo error or something else. Is this clear? Static typing versus dynamic typing, is this clear?
Yes, ma'am.
Okay. Okay, now let me ask you something. So when I say data types, what is the immediate thing that comes to your mind? Can you tell me some examples?
String.
Int, char, float, string, boolean, double.
Yeah. Right. Now suppose I want to declare, sorry?
Long.
Yeah, long, double, all these things are there. Right. Okay. So now I want to ask you something. Okay. I want to declare a data type, which is something specific to my requirement. Say, for instance, I want to have something like a user-defined data type. I want to declare something which is specific to the application that I'm developing. Say, for instance, I'm going to automate the administrative activities in a company. So there are many employees and I want to automate the payrolls. Now I want to save the full details of an employee as a single entity. The employee ID, the employee name, the employee basic pay, the joining date, the date of birth, everything has to occur as a single entity. This I will declare as a data type. That is employee itself. I will say it is a type, employee type. This is a user-defined type. These are all like what are given by the programming language, right? But this is a user-defined type. Yeah.
Is it where you're trying to explore the abstract data type and all that stuff?
Sorry?
Is this where you're trying to explore the possibility of abstract data types or, something of that sort?
Yeah.
Like a class,
like a class, yeah.
Something.
Okay. So let me just tell you something. So if you have a doubt, please ask me. And until the end, if I am not bringing up this abstract data types, please, you can ask me at that point, okay? Because I understand that you are like really excited and trying to answer more than what I've just handled. The thing is, like, there are people who have not watched the videos, and it probably is a distraction for them. Okay. So if you have a doubt in whatever I've explained so far, please ask. Whatever you thought was where I was taking into and I'm not doing it, at that point, please interrupt and ask us. Okay. Is it okay? I mean, if you are asking me whether I'm going,
Yeah, sure.
got it, no? Okay, yeah. So if I tell you, like, okay, I'm going to teach you abstraction, I'm going to teach you abstract data types, it's kind of difficult. More than that, I'll tell you what I'm trying to say. And then I tell you, okay, this is the name for that. That's kind of more intuitive for people who are hearing it for the first time. It'll, at least that's what I personally feel. So that's why I'm going that. Okay. Now you have the employee type. What I want to do is this employee type, right? So it has some set of data, which I've already said, right? So it has an employee ID, it has the employee name, it's employee date of birth, and okay. Employee basic pay. Now, this is a type that I'm defining. Now, I also want to define the behavior of this type. Say, for instance, int, I know what are the operations that are permitted. I know addition can be done, subtraction can be done, multiplication can be done, division can be done. But for char, can I do that? I cannot do that. So I know the data type, and I also know the operations that are associated with that data type. But when I say for instance, A into B, right? Say C equal to A into B is what I'm saying. Do you know how multiplication is happening? Whether it is repeated addition or something else which is happening inside the CPU. Do you know how this is happening?
No.
No. So the implementation detail of this operation is hidden from you. You simply use this operator as if it is a default thing, right? But inside, the computer doesn't know how to do the multiplication, right? Somewhere it is programmed. The computer, as I keep telling you, it's a hardware, doesn't have intelligence of its own. It's all what we have given it is what it has, right? So eventually what the multiplication operator means, that is actually programmed somewhere, but it is hidden from the programmer. Like if I want to use C equal to A into B, I don't know how A into B is done. The implementation details is hidden from the program. Got it? The same way, I have a data type and I want to define a set of operations that can be used on these employees. That I will add it as say something like, okay, public I'll give data, okay. Get employee ID. Okay. Get or double basic pay. Double basic pay means I want to double the basic pay of the employee, or increment basic pay. So these are the behaviors. These are the behaviors that I'm expecting the employee data type to have. These things I define as methods or functions inside the data type. So the data type has a set of data on its own and a set of operations that can be used to manipulate the data. This together, right? So as I told you, the operation is here. The implementation detail of the operation is hidden from you. And you have these methods and the definition is from, if the method is hidden from you, right? Then this is an abstract data type. You are actually abstracting out the unnecessary details. All you need to do is, as a say, for instance, you are somebody in an organization who is just trying to make use of the data that is available. You don't want to code or anything. You want to know how the doubling is done. You don't want to know how the employee ID is manipulated or anything like that. You don't want to know any of those things. All you want to do is you want to know what are the behaviors available. What are the things that can be, what are the operations that can be performed on this data type. So abstracting out these unnecessary details, right? This is what? The data plus a set of operations. You know what are the operations of it, but you do not know the implementation details of that. So for every such data type, right, you have something. So for instance, say you have this method, say, get employee. Okay. Now the get employee ID, now I'm coming to the Python programming or maybe Java programming. In the case of Java, you declare, there are so many things which are known as access modifiers. Right? For those things you can forget because we have, lectures dedicated for that. You can just forget about it. But you should know what this program is returning. Say, for instance, if it says get employee ID, it should return employee ID. Then we should specify here int, mentioning that this method should return employee ID. Okay. Yeah. This part of the code, which I need to use, right? So in my code, if I'm going to make use of this class, I'm going to, in my code, I'm going to make use of this data type, which is employee. And I should know the behavior of the employee class. I use this method. I just need to know this part of the code. I don't need to know this one. I don't need to know how the basic pay is calculated, how is the double pay calculated, how is the employee ID retrieved, whether it is some kind of encrypted employee ID, whether some decryption is happening inside. I don't have to know any of those things, but I should know this part of the code. For a method, this is known as the interface, and this is the implementation of the method. The interface is what the outside world knows about this method. Say, for instance, even in Python, right? You have the sort method, no? You have the sort method, right?
Yes,
People
ma'am.
don't know Python. Do you know which sorting algorithm is used?
It is not specified.
Yeah. So that is the implementation details that you don't even need to know. All that you need to know is where you can use the sort. Got it, right? So the interface is the name of the method. In Java, the return type is also important, and the arguments to this method. Say, for instance, you're using the length method of the Python, right? You should know the argument, what should go inside the argument, right? So what is important to know is what whoever is going to use that particular class or object or data type should know. That is the interface. That is what is the user interface of a computer? What we see in the computer, right? But we don't know what is inside. The interface is something that you see, you should know. The implementation is actually hidden in the case of abstract data types. Is this clear?
Yes, ma'am.
So, ma'am, so the interface includes both the arguments we pass in and the return the value. Both together is called an interface.
Yeah, because otherwise, how do you know? Like what?
Right.
See, when you are giving the length and you give the argument, you don't know what argument you have to give. Then doesn't make sense, right? So the function we call is this is the method signature. Sorry. We call this as the method signature.
Right.
So we must know this in order to be able to use that behavior, use that operation. Say, for instance, this star, right? Star, what I mean by is the multiplication operator. It has to be preceded by a numeric value. It has to be superseded by a numeric value, right?
Right.
You cannot put one integer here and one character here. Got it? No. So this is, even though it is not typically a method that is there, you should still know what are the arguments that this operation is taking.
And
so
the
this is
return
the
value
interface.
also.
Return value also. Return value also. You cannot allocate it to a string, right? String C equal to A into B. I mean, at least in Java, you cannot do that.
Right.
Right? When you multiply something, you should know what is the return type. Only then you can receive it the appropriate value. Okay, so that is the interface. So interface is generally known to whoever has to use that, whereas the implementation details is hidden. This is the abstraction that happens. You are abstracting out the unnecessary details. You are only exposing what is needed. In Java specifically, this is very, very important because there are so many built-in classes and packages which are available, which you can just use without knowing anything about what is there happening inside. Okay, so that will come to. Okay, so this is clear. I'll move on to the next one.
Ma'am?
Yeah.
What you just described, is it abstraction or abstract data type?
Okay, so the employee that I'm talking about with these methods is an employee abstract data type. The whole concept of hiding the implementation details from whoever has to use it, the concept is abstraction.
No, how does a data type different from an abstract data type?
No, data type, abstract doesn't differ. Abstract data type is something like a type of data type.
What is the difference between the two when somebody says a data type and when somebody says an abstract data type?
So see, abstract data type is what I'm saying. That you have a differentiate possibly. Abstract data type is where you hide the implementation. It is data type is a generic word for that. I'm not even sure if you need to define. Yeah, I'm not sure. Okay. So can somebody give me an example of some abstract data type which is okay, maybe I'll come to that with other topics.
Queue and stack.
Sorry, yeah, queue, stack. Correct. These are all like they have their own data with set of well-defined methods on those, right?
Yes.
Class.
Yeah, class is a language specific terminology for an abstract data type, like Java specific terminology, right? Or maybe some other languages which use the class is nothing but data type only. It just means data type. Okay. So the next thing is okay, so I was just describing about variables, right? So I want to discuss something about some specific things about variables. So there are two terms which are mainly associated with variables. One is scope and that is length. So in order to be able to understand that, you should know how the methods are invoked in programming languages, right? So say for instance, in Java, Python, everything, say suppose you have a main method, okay? In Java, generally the execution starts from the main method. So this is some confusion that people who come from Python to Java has. The entry point to any application. Java, every time you want to start hand running the execution of a program, so you want to try out like how the execution is going to happen, always start from the main method. Never forget this. The entry point to any Java application is starting from the main method. Okay. So you have a main method and it has a number of arguments in the case of Java, but here you can just assume it's a. Okay. Say you want to add two numbers, say A equal to B plus C. But before you want to add C, you want to double C. Okay, so maybe I'll just say double of C. So double is a method, and then I want to say print. Now double is another method. So double is actually going to. So maybe double is not a right example. Okay, let me just put it as square root. See? Now I want to see, here I want to see is negative of C. Okay, some Boolean value B equal to is negative of C. If B is, if not B, I hope you are aware of these symbols from Python, right? If not of B and all these things, right?
Yes, ma'am.
If anybody has any doubt, please ask me. I'm assuming to some extent that you have, you are still able to recall Python basic things. Otherwise,
what is this B? What is this B, ma'am? Small b?
B, B.
B.
It's a Boolean value. So
okay.
Writing I know. One second. So I'm just getting some Boolean value. Okay. Is negative C, if not B, then return. You have some method that will compute the square. So square root, actual square. Okay. And I'm not going to write the. So here you have say actual square. See. So return some method it moves. Okay. Now what happens when this sequence of events happens? So it coming to main method. Then from this statement, it will go to the square root method. Then from square root method, it goes to, sorry, I'm really sorry, that's not what I meant. Math.square. This is not the
What is this method, ma'am? Is it a function?
yeah, it's a function. It's a function. Yeah,
Fun-
methods, functions are all synonymous. You can use it
Okay,
as
synonymous. Okay.
yeah, functions. There are subtle differences, but you can forget it. Is negative. So this is another method of say N or now what happens is if N less than 0, return true, else return false. So this is the implementation of your is negative. Okay. So
These
you have
curly brackets stands for a method.
block in Java. Yeah, block. Not in just in Java. In most many programming languages, you have a curly bracket.
It is a block.
Block. Yes, it is a
Okay.
block.
Okay.
Yeah. Please keep asking. Yeah, thank you. I mean,
No,
we
whether-
kind of
whether-
assume
whether-
certain things, no? So please, feel free to
Whether
totally
this
interrupt.
block, ma'am, it should be written in the same pattern or anywhere we can alignment we can do.
Java doesn't worry about indentation at all, but these braces
Okay.
are mandatory if you are putting.
No, braces
if-
should be there, but if you whether
No,
we can
indentation is not mandatory at all. You can actually write all these things in a single.
in continuation also.
Yeah. You have
Okay.
to separate everything by the semicolon, but I'm
We
not
are
putting
writing-
those things here. I'm just writing.
We are
it's like a
writing here just to
pseudocode.
understand so that we
Correct,
can understand
correct.
it is a
I'm
block.
not,
Got it.
yeah. So actually, I'm not taking to Java at all. No, I'm actually kind of using a pseudocode which has little bit of Python, little bit of Java, everything.
Okay, okay.
So as long as
Right.
logically it implies, you can don't worry about it. Java
Okay,
definitely next week only we are starting using that.
Okay, ma'am.
Yeah, sure. So please feel free to interrupt, ask even such basic things, because there will be others also like you who are the same now, right? So please ask. Okay, so you have the main method. Now what happens with the main method, right? Inside the system, there is something called as a stack of activation records. An activation record is a set of memory locations which correspond to a function which is being invoked. So first time the main method is invoked, it is put into what is known as a stack. So this is the activation record of main method. Okay, this is the activation record of main method. So what does the activation record contain? The activation record will look like this. Okay, this has say variables which are used inside this method. The local variables say A, B, C. It will also have many other things, but two important things, one which is return link and the other is control link. I will tell you what these things are. For every method, there is an activation record. This is for main method. Now this record is put as such into this stack of activation records. So an activation record for a method contains all the details that are required for that execution of that particular method. So why do we need a stack for the activation records? That's what I'm coming to.
Main is also a method, ma'am.
Main is also a method. Yes, very much.
Okay.
Main is also a method. In Java, main is very much a method, and that is also to be put inside a class. Those things we will come to it. Okay. For now, main is also a method, just like the square root method and the is negative method.
Okay.
Okay. So main has an activation record which contains these details, and you have a stack of activation records. The first main method, when you are actually entering the main method, execution main method, it is pushed into this stack. Okay, and it has all these return link, control link, everything. Okay. Now it reaches this line and it sees that, okay, there is this method which is being invoked. Now what it does is, before going to the print statement, the control gets transferred to this method. Now, an activation record for the square root function, right? The square root function activation record looks like this. It has the C variable, B variable. It has a B, C, and again it has a return link and a control link also. Now the activation record of, you can see inside the stack, we push the activation record of square root method. Now once a square root method executes here, boolean equal to, then it sees that, okay, there is another method called which is happening, which is negative, and the control gets transferred from here to here. At that point, activation record of is negative method gets pushed into this stack, which is AR of is negative. You get this so far? Why? I will tell you why it is being pushed. I will tell you. Okay. Now, the execution, what happens? It checks here. It has got the value of n. It checks whether it is less than 0. It is 0. It returns
Then
to.
how, ma'am, this is in the activation record will come into the stack because we are calling the function is negative.
No, that is taken care of by the operating system and the JVM. Pushing into the activation record is not done by programmer at all. Programmer doesn't know anything. This is implicitly what is happening. This is the memory management part of it. The memory management of how the program execution and everything happens. Because it is important for you to know this so that, it becomes easier for you to understand how the memory allocation happens when it is parent class, child class, dynamically.
It will be done in the primary memory. It will be done in the primary memory.
It is all in the primary memory. Yes.
Okay. In the arithmetic logic unit like that, right?
No, arithmetic logic unit is part of the CPU. My main memory is RAM, as I told you in this figure, no?
Yeah, primary memory. Yeah.
So you have the
got
CPU
it.
here.
Got it, ma'am. Got it.
Yeah.
Primary.
ALU,
in the primary memory. Yeah.
ALU is part of
in
this
the RAM,
primary
RAM,
memory.
RAM.
Is correct. RAM.
Yeah. In the
ALU is
RAM.
here. Don't get confused with RAM.
Yeah,
is
got
here.
it. Okay.
Now, this is the stack of activation records that you have. Okay. Now, okay, you are executing the is negative. Now, this has to return the square root of C. Or it has to, sorry, I think I lost it. Yeah, return true, right? It has to return a true or false value. What it does is, then the control gets over. Okay. When the control gets over here, this control has to be transferred back to this line, right? Because whatever value it is returning, it has to transfer to this value. So it has to go back to this line, right? Now, it has not just to control, it is not just the control that has to go back, but it has also to return the true or false value to this method. Otherwise, if this execution of this method is over, how will this method know what is a true or false value? What do you mean by the return value, right? Once the execution of this statement is over, this activation record is popped out of the stack, meaning that this record is no more valid. This method is no more getting executed. So when it is popped back, the value that it returned, the return true or false, has to be communicated back to the calling method, which is the square root method, square root function. Yeah. How do you do that? There is a return link and the control link, which I was talking to you about, right? The return link will have some address, some memory location address in the RAM somewhere else. Okay, so this is all happening inside the RAM only. So inside the RAM, say it has 123. This is a memory location which is stored here, say 123. The return true value is actually stored inside that 123 memory. So now the square root method knows where to find the return value. The square root method now knows the where to look for the return value, which is returned by the is negative method. It goes and looks at this function once the record is popped out and the control is transferred to this method. But then the control, so this may have say 100 lines here, and it is after that this is negative is coming. So how does the CPU know that, okay, I have to go and start, resume the execution from this bool statement, right? 100 statements over, I have to start re-execution from the 101st statement. That is stored in the control link. The control gets transferred to which location? That is stored in, say, this is say 236. So there are so many locations here. At 236, it will say, okay, here is the instruction which you have to execute. Or here is the location of the instruction where you have to execute. So basically, the return link is the address of the location where you have to store the return value. Control link is the address of the location where you have to come back and continue the execution of the program. Okay, so that is what is happening in the activation record. It has a return link and the control link. Now,
Once more, ma'am, please, once more, control link and activation link.
And what is
Once,
control link
please.
and return link? Is it?
Yeah,
Okay.
yeah,
So
yeah.
let me just ask you. Okay, there are 100 lines.
On a place page, ma'am. This
Fresh
control
page,
link.
okay.
Yeah,
Okay. One second. So you have
in
main
a stack,
method.
Yeah.
Main method, which is computing say A equal to B plus, what would be right?
Anything.
Square
Ma'am.
root.
Yeah,
Okay.
Square root.
Square root of C. Okay. Yeah. So then I have a print A. Okay. Printing is square root of C. Whatever. Now it is taking whether, so Boolean B equal to is negative of C. If not B, return to, I think this is what I wrote, and return false. No, sorry.
Return what?
No, we have to return the square root only. The other method has to return the Boolean.
Yeah. It's negative. The square root is complex.
So if not Boolean, return. I'm writing mat dot square root because you know that's how it's done in Python, right? Now I have is negative method, which is taking something. If n less than 0, return true, else return false. Okay. So this is a Boolean, and this is an integer value. Suppose integer, I mean, just assume. Now inside the stack, you have like this, which is AR of me. Okay, AR of square root and AR of is negative, right? So let us see. This is the like a bigger picture. Okay, this is negative. Now this is gone out of the stack. Now you have the activation record of square root. This has its own variables, say B, C, etc. And here it has the return link and the control link. Okay. So what I'm saying is here there are say about 100 lines of code. The control gets transferred to is negative method. Then once I finish the is negative method, right? Once I finish execution here, it has to come back to this line, right? How does the JVM know that? So that controlling where the memory location of this instruction is, that is actually stored in this control link. Control link is a pointer to the location where the execution instruction from where you have to continue the execution. Control link is where the control gets transferred to the program control. The program execution control has to be transferred back to. See, it cannot transfer control back to the beginning of the square root, right? Doesn't make sense, no? It has to transfer the control back to this line so that it will continue execution from there, correct? Is this okay?
Yes, ma'am.
Anybody has any doubt? Control link?
I am one.
Yeah, absolutely.
So control link has the information like memory location of that method.
Yeah, so generally we say control link means some pointer to some memory location. It could either be a pointer to another memory. So depending on the implementation of how the JVM or the operating system does it, it could be another pointer, it could be another pointer, it could be another pointer. All that you have to understand is the control link gives the information as to where the program execution control has to be transferred back to.
And is it AR, like we are pointing to that AR of it, or
No, I did not understand. What is it? Is it pointing to?
is it pointing to activation record or memory and activation record are different things?
No. The control link has to point to where the instruction is there. Program instruction. No, activation record is specific to a method which contains its variables, all the details that are required for the execution of that method. The instructions are elsewhere. So it contains the information required to return back to where it transferred control to this method. So it transferred control to the is negative method from the bool b equal to is negative. And then it has to come back to that statement to continue execution. So that information is stored in the control link. Okay. Now return link contains the information as to where the return value will be stored. The calling method needs two information. One is where to resume the execution of the program from. Second thing is where will it find the return value of. That is all it needs to know. It doesn't have to know what are the things that happen inside the is negative method. All that it knows to continue its execution is where has the execution to continue from and what is the return value from the method which has been invoked. These two things are given by the return link and the control link. So don't worry too much about it. These are all like specific, further, too much finer details. If you try to understand, it will be more confusing. Just understand it from a very broader perspective so that you can understand whatever is required for the future weeks is what I'm trying to motivate you from here. Okay. So don't think about whether it is an actual address location which is pointing to another location or it is actually containing the value. All those things, don't worry. Just understand it contains the information as to where the control execution has to resume from and also where the return value can be found. That's it.
It is
Okay?
just about
Excuse me,
knowing
ma'am.
whether it is what is happening inside. Just a broad idea about that.
Correct. That's it.
Okay.
Other things are like more operating system subjects, which we don't have to worry about.
Okay. Okay. Thank you.
Yeah, someone else was.
Ma'am, basically control link points to the previous activation record, right?
No, previous activation record is not, you see control link, you actually need to know where the program execution has to be continue, right?
Ma'am, but in the videos, like in the week one videos, it's mentioned like a control link points to the previous activation record.
Yeah, previous activation record, this is not exactly the previous activation record, the instruction of the previous activation record where the control has to resume. You can read some operating system books, I would say, if you are a little unsure.
And ma'am, one more thing.
Yeah.
In the lecture, there was one thing which was explained. For example, we create a function, and in that function, we suppose create a variable a. And then in that in the function there is another function used which also has a variable called a. So ma'am, for these two a variable we'll have separate activation record or the same like.
So in this example it's like this has a b and this also has a b, right? Main has a b. The mains b will be here, square roots b will be here. No? That's what your doubt is, right?
Yes ma'am. Like
the mains b will be here, the square roots b will be here.
Okay.
Yeah, I think because they will have different memory address. So I think
they will have different memory locations and that will be taken care of by the system.
Ma'am, because like in the I think like we can't discuss the graded assignment questions here, right? But in the graded assignment question, there's one question where the options are a bit confusing. Like it's similar. Like the way you have explained here, it's similar. Like they have used X, Y, and like Z variables, but there's a function within a function, and in that function also we are using X, Y something, and in the function which this function is, there also it's X, Y. And the questions are like the same activation record or the different, like
See, there are we are not discussing this with respect to Java specifically, right? We are generally discussing with concepts which are in general. So there are programming languages which support nested functions also, right? I mean, have you heard of such programming languages? Nested, so function within a function and all that. In such cases, what happens is the variable which is used in the outer scope, the outer function, might be used within the inner function also, right? So that will have a global scope, something like that. So don't confuse yourself with that. Yeah.
In Python, it's the case what you are telling. And because actually that code in the question is written in Python. So that's why.
Okay. So no, I did not understand. So you mean?
Excuse me.
So it's possible, like this nested thing is possible in Python.
Nested means you are talking about function definition within function definition or function call within function call.
Yeah, ma'am. Function call within a function call having same variable, like a same variable of same
function
name.
Call within function call is not nested function. Function definition within a function is called a function nested function. I don't think that is there.
Sorry, my function definition. My function definition. Sorry.
Are you sure?
Ma'am, there's a question where they have defined a function called function1.
Okay.
And there's a variable like y is equal to x plus 1. Then within that function, they have defined another function like function 2. And in that function, we are having this variable z.
Is it definition or invoking function?
Ma'am? I mean, it's the definition. Like they have defined the function this way.
Can someone else clarify overseeing this question?
He's trying to ask how does scoping work in Python? That is a simplified question.
Python, I have no idea. Like I don't think I want to discuss it because I'm very beginner at Python.
There are two types of scoping now.
What is scoping and how does it work in a language is what is this question.
Okay, hold on.
Basically,
one second. So yeah.
Yeah, ma'am, let me explain. In the question, like in the grid assignment question, there's a question where the code is written in Python. And in that question, basically, they are trying to ask like for this variable, will these two variables will be stored in the same activation record, or will separate activation records will be created for each variable? This is the question. And we have been given the code which is written in Python.
So
each one grid assignment questions.
So basically what the question is trying to ask is, how is scoping working in Python with respect to activation records?
Like, and when the question is question number 4 of grid assignments.
Yeah, I saw them.
Ma'am, I was a bit confused with that because in the video lectures, like when you pointed out, like I didn't initially realize that the code is written in Python, but now I'm realizing it. But in the lecture, it was like even if the variable have same name, but the functions are different, so they both will have separate activation record, as you like just explained here also. Like B will B variable, but they are in different functions, so they will be stored in different. But here it's a bit confusing if you see.
Yeah, so with respect to Python scoping, I have to check. Okay, I have no idea. Seriously, I haven't done that nested functions mistakenly. So I should have seen the question. I should have looked at it, but yeah, apologies. I'm not sure. I haven't checked it. I will check
no
it
problem.
Maybe in Saturday session, maybe we'll discuss this. I cannot discuss the graded assignment question, but
yeah, ma'am. I was asking just that. I knew that we can't discuss the complete question here, but ma'am, it's a bit confusing. The options and all.
I cannot hear you. Yeah, your voice is a bit distant.
Yeah, ma'am, I was just saying that I was getting confused because of these options and
Yeah,
all.
yeah. So I
Because
think you will have to look for some Python scoping
okay, ma'am.
information from somewhere else. Okay. I
Even
don't
ma'am,
think I
when
can
you
help
said
this.
when you mentioned this thing that it may be different for different languages, then I realized that the code is written in Python. I was just thinking that it's Java, but then I
No,
realized
no,
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 it's
no.
written
That
in
is
Python.
Python only. Java
Yeah.
does not have functions within Python. Of course, the nested classes and all those things are there. But yeah, again, that can actually that has actually local scoping only. I don't think it has a global scoping, but I have to see. Yeah. So, but Python, I am not sure. I have to check. Like I have no idea. I have to check.
I mean, Python only functions create scopes.
Ma'am, excuse ma'am.
Yeah.
Ma'am, and can we define a function within a function? Like, is it possible?
Where? In which language?
Python, as they were discussing, they are discussing on Python language, like function defining within a function. Is it
I
possible?
have not tried it. I have not tried it. Must be possible. I'm not sure.
Yeah,
So,
we can.
Nalini Anand, can you give some
It's
insight?
possible,
Maybe other people who are, who are
Ma'am, it's
quite
basically like decorators.
comfortable.
In Python, ma'am, I know that it's possible, but not about
Yeah.
Java. I can't say.
Function within a function not possible in Java, man.
Java, you can have this nested classes which has nested methods. No?
We can write class within a class, but we are not able to write nested methods.
Yeah, we'll come to that. I think it will be we'll come to that. I'm more worried about. See, that question is given so clearly it is possible. Okay, nested function. Only thing I am not sure about the scoping of variables. But
in Python, ma'am, there is no need to write a nested function because once you define a function, you can use all over the program. That function will work.
And ma'am, any language will follow either dynamic scoping or static scoping. So according to dynamic scoping, the y should be same as mentioned above outside the function. It should be.
no, I'm not sure I understand all these sophisticated terminologies, to be honest. So these are from the Python jargon. I'm sorry, I'm not well versed with it. But
Okay,
yeah.
okay, let us proceed.
Maybe I should have done a little more investigation on that before, because especially the for week one has a lot of Python code, right? Maybe next session I'll be more prepared. Okay.
On discourse, we will put question on discourse. It may be discussed
sure.
there.
That will be better.
Okay.
There will be a lot of
That,
people who knows.
because a lot of people will expert will be there. They will reply.
Correct. They'll be.
Let us proceed, ma'am. Here.
Yeah, sure. Okay.
Thank you.
Okay, so for now, let us just assume this scenario where you do not have, functions within functions and this overlap is not there. In such cases, this is clear, right? The activation record, how the variables contain, what the return link means and everything. No? Return link and control link is kind of clear now, right? Is it correct?
Just a quick question on this. There can be, first question is, there can be more than one return link, right? If there are, the calling method has two variables, for example, to be computed.
Okay, so I see at some point, say suppose you are saying E is negative plus E is positive or something, right? This is what you mean?
Right, something like
so
that.
First it executes E is negative, right? And once the E is negative is done, this record is popped out, right? So that return link is there. That value it knows.
Right.
Correct? Yeah.
Then
then it stores
again
in some temporary variable or something. And then E is positive is actually popped inside. So now the return link. So it can either distinguish. So again, it's all there in the finer implementation details, depending on how the architecture handles it. Whether it again stores in a kind of an array, all these kind of data, returned variables, right? Whether it is stores in array or whether it is putting in the queue or how the finer implementation details are. Like we don't need to really go.
Sure. And the other question I had was the control link is basically from the calling method or the parent method that's calling this, right? So it basically returns the control. It has the back to the parent method.
Correct.
The return link, however, doesn't have to necessarily be to the parent calling method, is it? Because, like, for example, if you're trying to store into some global variable that is that's been called from some other method.
So what do you mean by global variable? That is the discussion that we had. So global variable must be if you have a function which is of a higher scope, like an outer scope, right?
Right.
So if there is a global variable there, then what happens? That's what you're asking, right?
Correct.
So that will have a totally different kind of, I would say, possibly another intermediate value, or maybe there is a space in the heap. So I'm coming to that. There is something called as heap. Apart from the stack, there is something called as heap, which is for something called a dynamic allocation. Okay. So
Right.
there probably they have some space which is allocated there.
So this return link is primarily just what this method is going to output back to wherever.
Return back to the calling method. Yeah.
Okay.
And in Java, it returns just one line.
Right.
Always you can just return one line.
One line. Yeah.
Okay. Yeah. So I think we have to move on because I had so many things planned, but I think that's okay. We'll discuss those things in the next class. Okay, so fine. Now, yeah. So activation record. Yeah. Now, what I was talking about, all these cases we are talking about is like int, boolean, etc. Right? Now, suppose you had something like an object, okay, user-defined object, say employee. You want to, so I'll come to what an object is and employee. But for now, all that you have to understand is employee is a type, and you can create an object which is an instance of the type. Say, for instance, int is the type, and A is the instance of type integer. Same way, employee is the type, and E is an object or instance of type employee. So E1 possibly stands for one employee, E2 stands for the next employee, E3 stands for the third employee, etc. But this employee is a type which has a set of data types, methods, everything, which is there for each of these employees. For them, like this will have the name, date of birth, employee ID, everything, but the actual values will be different for each object. This is clear? This is the idea of type and instance. Employee is the type, which is like a template. Instance or object is like one particular instance of that type, one particular employee. So when you're saying an employee, so employee has these characteristics which I have defined, and these are the operations that you can do on this type. But I have created 3 different instances of the employee type, each of them representing one particular employee. So E1 is the name of employee. E1 is say something like Ram, this is Shyam, and this is Ramesh or something, right? Now, suppose in my activation record, right? So you have the activation record of some other. So of course, main is there somewhere here. I'm saying some other method. Okay. Let me put it as get bonus or something. Okay. This is the employee. This is the method of this. Okay. So once again, get bonus method. And this has, say, salary as an object. Salary by default can be an integer, but I am defining salary as a type. Okay, so which will define, say, in the salary type has these values: int, which is the basic salary, then int, which is the DA, then int, which is the bonus. All these together becomes one salary type, and I'm creating the instance of salary type inside this method get bonus. Of course, this get bonus may be a method inside the employee type. Okay. Now, the point that I'm trying to say is, we say the variables, right? So we said X, Y, etc. Suppose I want to store S here. Then this happens as a dynamic allocation. During runtime, the memory is allocated to a particular instance of this type inside what is known as heap memory. So until here, say you have stack, the RAM, and then here you have heap memory. Now I want to store the object of type salary here. I'm going to not store the value of S. Instead, I'm going to store the address of S. And this address is a location in the heap. Here I will have, say, the basic pay of S. I'll make it more clear. So this is the heap that I have. And I'm storing, say, S object here. So I have, for S, I have the, what are things I said? Basic pay, DA, which is dearness elements, and then you have, say, bonus. All these are stored, and it is stored here. This is the earlier point. So here, I'm not storing the actual values. Instead, I'm storing the address location of the object. So apart from the primitive data types, right, the objects which are user defined, these are allocated memory in the heap. This is the dynamic allocation. During runtime, when you want to create an instance of a type, you are creating the instance, and inside the activation, all that you have is the address of that object. The actual object is stored inside the heap memory. This concept is very important because many a times, many people are confused about this dynamic allocation. So it is very important to know that the local variables, right? The variables which are local, this primitive data as local variables, these are all there in the local variables have the actual data inside the memory, whereas these objects, they will have the reference type. We call these variables as the reference type. This reference will point to an object of that particular type inside the heap. Is this clear?
Ma'am, can you just repeat it once again from this?
See, you have a type salary, right? Just like employee salary is also a type, which I have defined here. No? Here. See, salary has these components, which is basic pay, DA, bonus, etc. Right? I want to create an object of salary, and I want my method, whichever method, this get bonus method, right? This get bonus method is inside the activation record, and it has an object of type salary. It is there inside this memory. Which one is here? It is not the actual object that is residing in the activation record. Instead, it is a pointer or an object reference to the object which is physically located inside the heap. The actual data, the variables, basic pay, DA, bonus, everything is there inside the heap. The pointer is inside the activation record.
Can we say only the primitives are in activation record and the rest are in the heap?
No, you can't really say that. So that's what I did. I just didn't want to generalize it. Maybe sometimes even you think that string is a primitive type, but string is generally treated as an object. So if I generalize it, it will become a little confusing for people. So the user-defined objects for sure.
When you say string, are you specific to the Java language or string in general?
I'm talking in specific to Java because this stack heap concept which I'm teaching you is something, I don't know for how many languages it is there, but definitely for Java, this is how it is done. I will also tell you something which is specific to Java. Say for instance, sorry?
Heap is also a memory location in primary memory. Heap is also in primary memory, like a stack.
Heap is also in the primary memory, correct?
Okay.
Yeah. Heap is also in the primary memory.
Okay.
So in fact, what happens is if you keep on adding to the stack, right, it will actually kind of override the heap. And it so happens that, in cases of recursion where you don't give the basic condition, right, it will give an error called stack overflow. This is what is happening. It keeps on adding the activation record with the same method over and over again. At some point, the primary memory stack space that has been allocated in the primary memory runs out. So it's not able to execute the program again. So it kind of, the operating system then shuts down the program, stops the execution of the program by issuing the stack overflow. Okay. So I'll tell you something specific to Java here. So suppose you want to create an object of this, you put new salary. This is the syntax. This I'm telling you, it is important because in the case of integer, you will just give us int a. Case of say float, you will give us simply something. But the case of objects, you create it as a new salary. Then what happens is there is an S which is created. The reference or the address location of it is inside this. But the new salary object, right? This is actually allocated space inside the heap. This is what is happening with this particular statement. It is allocating memory inside the heap for an object of salary type. Okay. Now, whatever you want to do on the salary object, right? Say, for instance, you want to access salary.basic pay, this is not basic pay and everything. This is the data is actually coming from the heap. Okay.
The new salary is also an instance of the salary, yes?
No, new salary is the syntax, Java syntax that you use to say that, okay, I want to create an object, an instance of type salary, which is referred to by the variable S. Whenever I say S, it has to refer to this new location that you're allocating. When I say new salary, then inside the heap, right, it allocates some space for S because salary, it knows, right, this is the data it allocates. Then it says, okay, this has to be referred by the variable S.
And that will be valid for that particular code, not for the all.
Sorry, I did not understand. What is it? Code meaning?
Means suppose a program is being written in which we are using the salary S is equal to new salary. Then this new salary will be used only for that particular code.
Yeah, inside that function only.
Okay, got it. Okay.
Got it. Inside that function, see the activation record is where the S is there. No?
Like local variable.
Like local variable only.
Okay.
Only thing is, suppose you give say return S. You can return an object also. You cannot just return integer, float, etc. But you can return S also. What happens in that case is you are returning the address location of that memory. Which one? This heap memory location. You are not returning, say, return 10. You are not returning return 10. You are not returning the value. You are returning the address location of that object to the calling method.
Okay. It means whenever that address will be required and we call some function calls that, then on that address, because the code will be there, that block will be executed, right?
But whatever is there inside the heap identified by S, the new pointer, say, for instance, you are calling, say, some method, say, as okay, you are returning S, say, right? So here inside the calling method, say, which is the method which is calling, say, some other method is calling, say, get bonus, and it is returning the salary, right? So that calling method will have, say, salary S1 equal to get bonus of something. So if this returns S, then S1 is now going to point to this location.
Okay.
Because get bonus is returning that S, right? S, which is the address of S is what it is returning. So address of S is being transferred to S1. So now S1 will start pointing to the location which is specified by S.
Okay.
Got it? Yeah. So this is slightly important because in the case of Java, what happens is you have a concept called inheritance. Inheritance is, there is some basic type. This again, I will explain the next class. Maybe I will not have time today. So there is some parent class, which is inheriting from the child class. Okay. So parent P equal to new child. This is something you can do in Java. So this is why I keep telling specifically. In this earlier case, we said salary S equal to new salary, right? So this, there is no confusion. I'm creating an object of salary and the variable reference type that is going to point to that is also of type salary. There is no confusion. But when there is a class, child class, which is inheriting from the parent, then if you create an object of child class, then you can have a variable of type parent, which can point to the child. The other direction is not possible, which is child C equal to new parent is not permitted in Java. Whereas the parent P equal to new child is possible. In fact, parent P1 equal to new parent is very much possible. There is no problem with that. What is also possible is parent P equal to new child is also possible. Is this clear?
Yes, ma'am.
That we will come to what is inheritance and what is the property, everything. Sorry?
And is it also called a superclass and the subclass?
Yeah, it's a superclass subclass relation only. That we will come to it. Don't confuse with all those things. But just understand that if there is a class from which another class is inheriting a lot of properties, I will tell you what inheriting properties mean. Then the parent class variable can point to an object of child class. The other direction is not possible. So this is something that has been very confusing for people who have been learning Java in the last episode. That's why I keep emphasizing so much on this. Okay.
Excuse me, ma'am.
Yeah.
The new is part of syntax for creating an instance or something.
Correct. That's correct. Yeah. So new is a keyword. New followed by the class name, and this is also part of the syntax. Okay. So we'll write employee E equal to new employee. So implicitly what this is doing, it is invoking something called as a constructor, and inside the constructor also you can have arguments. All these things we will explain later. Don't worry too much about it. Just want to tell you, this means that it is creating a new object of type salary, and a salary type reference is pointing to an object of salary type. In this case, a reference type variable of type parent is pointing to an object of type child. This is permitted in Java. Okay.
Am I audible?
Yeah.
Yeah. So this part I did not get very clearly. So in Python, there was an example. MCQ is a class, and question is a class, and MCQ or NAT is inheriting from question. So can you explain this in terms of question and NAT?
Yeah. So this analogy is something everyone understands here because you have studied Python.
Yes, ma'am. We can discuss here.
Okay. So see, suppose question is type. Okay. So question will have, say, question statement, which is problem statement, and say some answer, right? Now, okay, maybe I'll just remove the answer for now. Okay, now I have, say, MCQ, which is another type, right? Which is MCQ, which is inheriting from. So here in Java, we say extends, or let me just put it, inherits from, right? Question. Is this correct? This is what you mean, no? Correct?
Yes, ma'am.
Now you have correct option, wrong option 1, wrong option 2, etc. These are the data inside the MCQ. But MCQ also has problem statement. Is it correct? So MCQ is inheriting from its parent question what the problem statement. But it has its own additional information, which is the correct option, wrong option, etc. Whereas if it was NAT, which is inheriting from question, see, inherits from question, right? So then you simply have an answer as statement, right? You don't have correct option and wrong option and etc. NAT is also inheriting from question class. MCQ also inheriting from question or class. Okay, class. Please understand class is synonymous with type because it's the same in Java, right? So the question is the parent, MCQ is child 1, NAT is child 2. MCQ is inheriting from question, so it has the problem statement also. So even though it is not explicitly stated here, the problem statement is also a data of MCQ. Same way, for NAT also, problem statement is a data here. But along with the problem statement, it has answer. It does not have these options because it is not inheriting from MCQ. It is inheriting from the question. Is this setup clear?
Yes, ma'am.
Okay. Now I'm going to say question Q equal to new question. Okay. Then question MC equal to new MCQ. Question N equal to new NAT. This is permitted in Java. Okay. Now, suppose you have functions inside the question. Say, for instance, I'm just going to write some get methods. Get method means you are just returning the problem statement. Some method. Here you are returning, say, get correct option. Okay. Here you are returning, say, get answer. Okay. These are 3 functions inside the 3 classes. Okay. Yeah. Okay. Now, you want to invoke, say, Q dot problem statement. So, I mean, I don't know if I will be confusing you more with this. So, you can actually create instances of MCQ and allot it to objects of type question. So, if I tell you like Q dot problem statement can be accessed, Q dot get correction option, sorry, MCF dot get correction, N dot get answer, these can be accessed. It will be confusing for you at this stage, right? Or do you want me to just briefly explain that? I mean, I'll be totally deviating from what I plan to do, but is this context clear? I don't know who asked about this question in MCQ scenario, but is this context clear for you?
It is clear.
Do you want to explain anything more on this, or is it clear, very clear?
Ma'am, see what is clear is in the first line is from a class you're creating an instance. Question Q is equal to new question. That is what is normal to us.
Correct.
At least for me.
Correct.
Why are you determining the second line is not normal because you're declaring a parent class. You're declaring the type as parent class for an instance of the child class.
Why is it required is what you're asking.
Like what are we achieving by declaring this way?
So this is, yeah, so that is actually a slightly complicated thing. So that we will come to it when we are discussing what is known as dynamic method dispatching. Okay. So what happens is, so dynamic method dispatching is during runtime, it decides which method instance to invoke. So for instance, this says get problem statement. This also has get problem statement because problem statement variable is part of this, right? It also has get problem statement, right? Now, if you say Q dot problem statement, right? It is invoking this method. If you say MCQ dot problem statement, you are not invoking the problem statement inside the question class, but you are invoking the problem statement method inside the MCQ class. If you say n dot get problem statement, then you are invoking the get problem statement inside the NAT class. Now, this is required. Say, for instance, you want to compute the area of say Q, or rather, you want to say you have a function, say print something. Okay. Now I'm saying question Q1. Okay. Q1 dot problem statement, get problem statement. Okay. Now I have another method, say here, which is invoking the print method. Say some display or show method or something. In which, depending on some particular case, say if something is satisfied, then I want to invoke the method of the problem statement method of the MCQ. Okay. So what I can do is I can create an object of MCQ class, and when I say invoke print of MCQ dot print of MCQ and print of NAT, right? This will still work. If this was not questions, if this was say MCQ, then I could not have invoked this. If this was NAT, then I could not have invoked this. But because this is questions, which is parent of both, I can invoke both print MCQ and print NAT when MCQ and NAT are of type this, but pointing to MCQ. Is this clear? See, question Q equal to, it was new question. Then I specifically want to invoke the MCQ of the print method, the get problem statement method inside the MCQ class, not the questions class. But I can transfer it here, and then I do a typecasting. If I will check which is the instance of this one. If it is of this instance, I invoke this, otherwise. So we will actually come to that. This dynamic method dispatching is runtime. You decide which. So there are 3 problem statements here, right? 3 get problem statements. This is one get problem statement. This is another get problem statement. Another. So during runtime, if you are invoking say Q dot problem statement, this will be invoked. If you are invoking MCQ dot problem statement, then this will be invoked. If you are saying N dot problem statement, get problem statement, then this will be invoked. During runtime, which method has to be invoked is a decision which is taken in say cases where you want to be able to decide during runtime which method you want to invoke. So we have number of assignment questions which will clearly give you an explanation as to where these things are useful. This is specifically like, you have, say you want to have something like a parent class which is shape, and you have say 2 child classes, say rectangle and say square, but you do not know which input figure is going to come. You still want to invoke the area method. The area method is inside the rectangle class and square class, but these two have 2 different definitions. So you want to invoke the area method inside one of the specific child classes, depending on the data type of depending on what is the input that is coming in. For this, having a parent type reference variable is useful because during compilation time, the compiler knows this get problem statement method is there in the parent class and both the child classes, and it is permitted. Whereas during runtime, it will check which type. Say for the user, whether the user is going to give the rectangle or the square, we don't know. They can give in any order. Then we take it a general variable, and based on what object is coming in, we invoke the area method. Maybe I'm not making much sense at this point, but as you do more examples and more assignment questions, you will get it. I'm just trying to explain a very broad and brief, very over, a top view idea about this thing. Why this is required? Why this? What do you say? This dynamic method dispatching or dynamic this particular being able to allocate an object of child class to a reference type of parent type is required. This will be required in many places, and we will actually show you even in programming questions this week.
I think the confusion comes from contrasting with Python, because Python doesn't ask for this type.
Correct.
But
So,
it still does the same thing. I mean,
correct.
it pretty much does the same thing, except
it
because
does implicitly possible.
implicitly, correct.
Yeah.
And you've already said MCQ is extending question.
Correct.
So why again defining question MCQs? I think probably the question. So as you
Yeah,
said,
so-
because we are compiling, it could be the reference because of that.
Yeah, so maybe when you see the examples, you will see why it is more specifically required or why is it useful. Maybe next time, maybe I can come up with a better, more usable example. Right? So whatever we prepared to discuss today, I would say even half was not discussed, but that we will do it in the Saturday session. We kind of went into the contents of week 2 and maybe even later. So when somebody asked that, I thought possibly, there's no point skipping because. Okay, anyway, so this is just a very brief idea about what is to come ahead. We have other topics to discuss, like let's see, abstraction I already mentioned.
Ma'am,
Yeah, sorry.
Yeah, we were actually discussing about scopes and lifetime. Like that's where
Oh
we
my God.
started
Yeah.
off.
Okay, let us come back to that. Yeah, sure.
Like you have the whole
That's
whole
what
thing and stuff.
Got it. Yeah. Okay. Let us just finish the scope and lifetime. Okay. So now what is the scope, right? So the variables have. I'll just finish this. This is something I wanted to finish. So whenever a variable can be referenced, whenever a variable can be invoked, called, manipulated, accessed, then the variable at that point is said to be in its scope. As I said, like we had I'm not rewriting the whole thing, it will take a long time. I'll just go back to the example that we were discussing. The main. Okay, shall we just stick to this one? So probably, I'm sorry about this bad handwriting, but let us just look at this. This variable A, this variable B, this variable C, right? This we are able to access from within the main method. From the square root method, I cannot access this variable B. But I'm accessing a different variable B. This is a totally different variable. From square root method, I'm not able to access this variable A. So the variable A is in scope inside the main method, but it is not in scope inside the square root method. Is this clear? The variable A is in scope inside the main method, but not in scope in square root method. This variable N is in scope inside the is negative method, but it is not in scope inside the square root method or the main method. Is this clear? Wherever the variable can be clear, okay. Wherever the variable can be accessed. Now the lifetime
about Java or is this pseudocode now?
This is pseudocode.
Okay.
Again, the scope and lifetime is something that is applicable across all languages. But if you're asking about these nested functions in the scope and even within the for loop and all that, that local, that block specific scope, right? Those things I'm not very sure with respect to Python. Okay, so that's why I'm not able to explain to you about the nested function. So this is with respect to this pseudocode. Okay, so what happens? Okay, so that is a scope. Now, what is a lifetime? Lifetime is when you have allocated memory to the variable. It may or may not be accessible, but there is some memory that has been allocated. The variable is alive. At some point, it will be accessible. So when you are inside the is negative method, the variable A is still in its lifetime. It is still alive, but it is not in scope. So with respect to the activation record, how do you identify variables which are in scope and which are in their lifetime? From what definition I have given you, can you tell me?
Ma'am, can you repeat that question again?
No, with respect to the activation record, right? So I'm saying in the activation record, there are so many variables, right? Can you tell me which are the variables which are in scope and which are the variables which are in their lifetime?
The lifetime variables in their lifetime are the variables that are actually active or present in the activation records that are in the stack.
Okay.
Right? And in scope means the variables that are accessible to the what do you say, the activation record that is active at the moment.
Yeah, which is the top of the stack.
Yes.
So which is the method which is currently active? Which is the method which has the activation record on the top of the stack, right? That's the currently active method. Why we have put the other methods at the bottom is because we want to come back to them at some point, but the current one that is being executed is the one which is on top of the stack. Variables which are inside the activation record, which is on top of the stack, are in scope, and all the variables, all the local variables that are inside the activation record, the stack of all the activation records inside the stack are in their lifetime, because we have allocated some memory to these variables, and by the time we pop out the other things, they will become active and they'll become in scope. This is the difference between scope and lifetime. Okay. Now, when a method execution is over, what happens is that method is popped out of the stack of activation records. That memory is freed up so that it can be allocated to something else. What happens to the memory which is allocated inside the heap? Say you want to return something. Sorry, someone asking anything?
No, yeah, sorry. I think my mic was on. Sorry.
Okay. So when you are popping the topmost activation record, that is actually getting removed from the memory, which means that memory is now available for other activation records or other memory. If the heap is going to grow towards the bottom, right, it can still occupy the space. In the case of heap, what happens is the dynamic allocation that happens, right? When I say the new something, so when I say new salary, then there is a dynamic allocation. A new object is being allocated space in the heap. When does this get cleaned up? So when it is returning the value, as I said, it has to be accessible by the S1 variable, right? Now, when it exits out of this method, the S1 is also not required anymore. Suppose I have done everything, I have printed the output, everything is done. I've moved on to some other method. But this S1 is still allocated space in the heap. Whereas for the activation record, this moment the stack is the activation record is popped out, that memory is freed up and it can be reallocated. But in heap, you do not know which are the objects that had to be cleaned up. So what happens is there are two ways to deallocate this memory. One is this programmatic deallocation, which happens in languages like C, C++, where you explicitly allocate and deallocate memory. Or it happens like in Java, it happens via what is known as an automatic garbage collection, which is invoked by the system. The operating system JVM, right? They both decide and discuss and maybe, okay, little bit of exaggeration there, but yeah, some point they invoke this garbage collector and the auto cleanup happens in the heap for those objects which are not currently in use. So again, these both have its own advantage and disadvantage. So programmatically, if you do it, we clearly know when we want to deallocate it, and we will not accidentally clean up something which is currently in use or anything. But then every program we have to explicitly state it. The case of automatic garbage collection, the problem is we do not know when the JVM is going to invoke. So if the program is running at that point of time, then it might accidentally kind of cause some problem. Of course, these things have a lot of foolproof techniques these days, but they're all like the basic idea about cleaning up you should know, like, in stack, it is an automatic cleaning. When it happens, when it's pushed out, it automatically gets cleaned, whereas in heap, it needs some explicit intervention from somewhere. Okay. So yeah, so that I think I will stop today. Yeah, sure. Sorry. Yeah.
So I was saying that we can't use a deconstructor in Java, like in C++, we can use deconstructor.
No, there is no, that's what I'm saying. Java does not have that deallocation. Explicit deallocation is not there.
Excuse me?
Yeah.
And we talked about the scopes and lifetime, but there was a concept that was discussed in the lectures called the hole in the scope thing.
Sorry?
Like there's a thing like the hole in the scope thing, right? Like a concept like that.
Hole in the scope, huh?
Yeah.
Where? Lectures.
Yeah, it was discussed in the lectures, like in the recorded
It's just referring
lectures.
to that point where the variable has a lifetime, but briefly it is going out of scope in between.
Yeah, exactly.
Then coming back in scope. So that's what is referring to.
Could you just shuffle that? Like,
So is it there in the lectures? Then I have to revisit.
Yes,
Yes. I will check
yes,
it. Can you tell me the lecture number?
I think it is.
Yeah, yes, ma'am. Actually, yeah, like
Yeah,
if there is a variable, like if the variable is
I think
declared globally, and if the variable which we declare in the some function like local variable is of same name, then if we try to access that variable, then that variable global variable won't be accessible, but only the local variable we will get. That is called the whole in scope, no ma'am. Like, yeah, actually.
Oh, okay. I think I understand. So this is again for, I think more applicable for nested functions, right? Where the function in the outer scope has a variable which is possibly accessible from within the function also. But if it is not, then the outermost function is still in scope, but the variable is not accessible from inside the nested function. I have to check. Look, so Nalini has just explained. Is that clear? Or I don't know.
My doubt was that is it like specific for nested functions, or is it because when we have variables, like if it is not nested, if you have a variable, let's say variable A in two different methods, like even though they have the same name, they point to different memory locations, right? So, but so that won't actually bring a hole in the scope, right? Like if one function calls the other from within that function, or is
No, it
it
is
when
not function call, right? It's a function definition that we're talking about, nested function definition, right? That's what the example that Nalini was giving, the global variable and the local variable, right?
Okay, so
sorry to interrupt. See, in the lecture, I think when the professor speaks, I think it's actually very simple. He says any variable that is not currently in scope, but during its lifetime, it's a hole in the scope. So even if, for example, the parent function has a variable, and then there is a function call that it does to method call it does to some other function. That variable has still got its lifetime, but it's basically out of scope. So
because
it doesn't even go beyond. I mean, global variable, nothing. It's as simple as just a variable going out of scope.
Yeah. So you mean the variables which are there in the activation records, which are not on top of the stack.
Correct.
All of them have a hole in the scope. That's what you mean, right?
That's how it is described in the lecture and in the slide also.
Okay.
But because the way I understood it, like again, I am new to Java and things like so, I might be wrong with this. So the way I understood is like if you have like just like in the case of nested definitions or something like that, if you have a variable and then a global variable and you have a local variable of the same name, the name of the global variable still like it is still there, but the data in that address is something else, so it cannot be accessed.
Let me ask you. No, if you are interpreting it that way, let me ask you. Say you have outside say function f1, inside which you have a nested function say f2, and f1 has two variables a and b, and f2 has another variable b. So do you mean to say that a also has a hole in the scope, or is it just b?
So like A is outside, right?
A and B are outside. B is there inside also. So by what you are saying, B is the one that has a hole in the scope, right?
No, A is the one. B is accessible in exactly. Yeah, B is the one that is a hole in the scope because
the B in the outer function is the one that is a hole in the scope, is what you're saying, right?
Yeah, it's something like that.
No, so as I understand from what I don't know your name, the person clarified. Sorry. So as I understand it, like whatever variables have been allocated lifetime, but because they are not accessible at that particular execution time, because they happen to be in some calling method which had happened at some point, doesn't even have to be nested at all. those methods which are in their lifetime, but not currently accessible, have hole in the scope.
Okay, so like,
It doesn't
okay,
have
so
to
it's
anything, you have to do anything with nested functions or global variable or anything. It simply means
okay,
all
yeah.
the variables which are there in the stack, which are not there on the activation record, which is on top of the stack.
Okay, yeah. So that clears it up for me because I was having this. I was confused as well. So thank you.
Yeah, so thank you. I don't know who clarified it, but yeah, I'm very bad at the terminologies. So I did not kind of skip the word hole in this. So about the other things that we discussed, see, these are all like really not required. Okay, Srinivas, you want to ask, or you said you were the one?
No. I just wanted one of the previous topics. I had one clarification. That is what I.
Yeah. Ask.
Ma'am, the way you defined abstract data types is slightly odd, and I find it slightly odd, ma'am.
Okay, what is odd about it?
See, suppose you want to go from IIT Madras to Chennai railway station. I am not specifying how to go, but I'm only saying go from here to there.
So what is the data type here?
No, I'll just come to that. So I'm not telling the method of transfer, but I'm just telling you to go from here to there.
Okay.
So this is the abstract, this is a general example. Coming to the abstract data type, like I have a collection of contiguous memory is my idea. The idea is abstract. Like how do I want collection of contiguous memory? What else you want to do over and above it is up to you. This is what an abstract data type is.
What do you mean by contiguous memory location?
Collection of contiguous memory. Matlab you want a collection, but the memory allocation should be contiguous in a continuous sequence. Matlab, it should not be a linked list, but what is generally defined as an array, language agnostic.
So do you mean to say that linked list is not an abstract data type?
No, ma'am. See, I defined my abstract data type as I want a collection which is a contiguous memory. You know what a contiguous memory is, right?
No, I don't understand in this context. What do you mean by abstract data type? See, where does data type have? Data type doesn't have locations, right? When you instantiate it, it has locations.
Ma'am, I am just defining what I want. I'm not telling you how to implement it. I have a certain requirement key. I want a collection is a set of items. But the set of items need to be placed side by side is my definition of it is what is called a contiguous memory. A collection which is a contiguous memory. I hope this is a language agnostic thing, not something specific to a language. That is what is an array. But the way you defined is you want to hide the way you want to go from Chennai IIT Madras to Chennai railway station. That is what is abstraction. Where you are saying, give me an interface, but don't tell me how I am going about it. Although
I am not getting what you're trying to ask, to be honest. See, if you are confused between abstract data type and abstraction, right?
You are defining, when you define abstract data type, it is leading more towards abstraction rather than the definition of an abstract data type. When you say ki, I don't want to worry about the interface. See, a data type is just a set of values and the operation on them. That is what fundamentally a data type is.
Okay.
An abstract data type is, I am not worried about the implementation part. I'm not worried about I just have a very generic idea, but I'll give you freedom what do you want to do with it. So when you define it this way, I want to give you an interface, but I don't want to tell you, that definition goes more towards abstraction rather than the definition of an abstract data. I hope I am making some sense.
No, is it clear for anyone else? Can someone else explain?
So I think like in queues and stacks, so fundamentally both are just a collection of things, but inserting into a queue is different from inserting into a stack.
Correct.
So I think that's where the abstract data type comes in. So I think that's where Srinivas, that's the point I think he's missing. Was
Okay,
I?
so stack is an abstract data type, right? That is something you are clear, no? I mean, Srinivas, you are clear, right?
And you start from an array. Then you go into stack, many other variations of it. See,
Okay, let me just check one. Okay, yeah, tell me. Okay.
Now you start with an idea of language agnostic array. And then you go into various types. In a stack, I am not telling me I can implement a stack as a linked list. I can implement a stack as an array.
Okay.
So the idea of stack is an abstract data type because I'm not telling you how to go about it.
Okay.
If you want to go about it as an array, as a continuous location of memory, go about it. If you want to go about it as a linked list, go about it. But I want certain operations on it. That is what I define my stack as.
Okay.
I am not worried about hiding something or giving you a continue. That is not the main idea of hiding. Is coming from abstraction, not from the when you define abstract.
Okay, let me just ask you. Okay, so you have the stack, which is I don't know whether you have do you have a built-in stack in Python? Do you?
We have something I think called a deque, which you can use, I think.
Okay, so in Java, definitely we have something called as a stack. Okay. Internally, whether it is implemented using linked list or array, we do not know. But there is definitely this method which is push or pop for a stack. Okay. So I know what the push does, I know what the pop does. But I do not know whether it is internally implemented using a linked list or an array. That is what I mean by hiding the implementation. Hiding the implementation doesn't mean I'm intentionally hiding from someone because I do not want to disclose it or it's something confidential or it's something private or anything like that. What I mean by hiding the implementation is that the user doesn't have to be bothered about the implementation. But the user has to know the interface for sure.
I think rather than saying hiding the implementation, it would be more appropriate to say you are open to any implementation.
No, I don't have the choice, is what I mean. The Java developer has done. No, Java developer has implemented it. I cannot say that, okay, Java developer, I need a stack which is done on linked list. Those details are hidden from me.
That is what, ma'am, the idea of abstract data type is not about hiding. It is about giving you an idea and not worrying about the implementation and not, you are focusing on the hiding part. That is not the part. What I'm saying is you give an idea.
Srinivas, let me just ask you one question. Let me just ask you, what is your background?
Ma'am, I'm an aircraft engineer.
Okay, so I mean, do you have I mean, your experience with computer science? May I know? Like, I mean, how long have you been programming?
Very little.
Sorry, very little. Is it okay? So I mean, why I'm asking you is because, like, is it this explanation coming from some use case that you have come across? That's what I wanted to check just by checking.
No, right from coming through this course, I've been going from this question. That is why what is the exact definition of an abstract data type has always been a mystery right from PDSA. So that is why I'm a little bit confused. Because the way you explain it is slightly different. So that is what I wanted clarification on.
Yeah, I mean, so to be very honest, I still don't get what your problem is, in the sense that what your confusion is. It almost seems to me like you are explaining exactly what I mentioned. Now, I don't understand like whether your confusion is between the definition of abstraction, abstract data type, or whether it is within the definition of abstract data type that I have told you and what you have read and what you have learned in PDSA. So I am actually not clear about that yet. You are just saying that my way of using the word hiding was not right. But I have read it somewhere, I have seen it somewhere, I've gone through it somewhere, and it also occurred to me that this is probably the most layman's language that we can use to say that hiding the implementations, right? Implementation, hiding, whereas the implementation is private, the interface is public. That's what the more general usage that we uses. So when you say private, it is hidden. When you say public, it is available for whoever wants to use it. Public interface and private implementation. That's what we say about the abstract data type. So have you come across this terminology, the public interface and the private implementation?
No, ma'am, this is more specific to Java. So this is only I've come across when I've taken up the Java language only.
So this is there in week 1 content, which is not part of Java.
Yes, ma'am. This part, mother, the private implementation, public, it is only mother. It is not there in Python, so it is not explicitly there in Python.
So you cannot say it's specific to Java. It is specific to programming concepts, right? So the week 1 content is not specific to Java. So you can take it granted for now that you can forget the word hiding if that bothers you seriously. But what you can do is just understand that the interface has to be public so that somebody can make use of it. And they do not have to know about the implementation, because how they use, they only should know how it behaves. They don't have to know how to make use of it. Or rather, they should know how to invoke it, but they do not have to know how it is internally implemented.
Then
does that come
then
to a
how
middle
does
ground?
then how does it differ from abstraction? Then how abstract data type differs from abstraction by definition?
Abstraction is the concept, is what I said. Like you are abstracting out the finer details. It's a concept. Data type is a thing as such. It is something like it's something like I mean, in Java, you can say that okay, you have a data type which is given by the class. So you want to hide certain things, then you have not a hiding really, but private data and okay, the implementation is something that the people, I mean, whoever is going to use, do not have to know about it. So I see you don't have to. Okay, so is this from a perspective of if this is about the perspective of clarifying your confusion with respect to definition of abstraction and abstract data types, you should probably read up more. There are standard Java textbooks. There are standard textbooks on object-oriented programming concepts. Please go through that. If my definition is confusing you more, you may forget it, because from this program perspective or from this course perspective, it's not very important. I explained it because these are the general programming concepts that you have for, especially when we are focusing on the object-oriented concepts. It's all the more important to define what the type is, what is an abstract data type is, and all that. And that is why we came to this. So if it bothers you, you can just ignore it for a while, and probably after some time, we can revisit this definition and see whether it starts to make sense.
Okay, this is okay.
Okay. So any other questions? Okay, so then we'll wind up today's session. Okay, we'll come back on Saturday. And so I think I have one or two things to look back at. I'll check that and come back on Saturday. Okay.
Okay, ma'am. Okay, ma'am.
Thank you so much, ma'am.
Thank you very much.
Yeah.
Thank you, ma'am.
Hello. Excuse me.
Yeah, Lee.
Yeah. Next class, like again, I know like there was an extensive talk on this, but could you like again give an example about this thing, the hole in the scope thing, like after, because
Lee, so just understand one thing. Maybe you should read up more about it, because it's not like really important from the course perspective. And there are so many things that I should have covered today, but I missed it out. These are like really, really minor things which, you know, you can either ignore or you can read up more about it from outside sources.
Okay.
Otherwise, we'll
All
just
right.
keep on dragging these, I know, not so important topics which are with relevant from the concept learning perspective, as well as from the, course, I would say the exam perspective or whatever, right? So even from neither perspectives, this is important. So we can actually have an offline discussion or something, but definitely not in the next live session. Okay.
Okay, sure. No, I just.
Sure. Okay, sure.
Thank you.
Okay, thank you.
Yeah, thank you, everyone. Bye.
Good night, everybody.